Imagine you're holding a coin, feeling its weight and texture in your hand. It's a simple object, familiar to us all. In our everyday world, when you flip it, the outcome is binary. It lands as either heads or tails, never both simultaneously. There's no ambiguity, no in-between. It's one or the other. This is the world of classical physics, the physics that governs our macroscopic reality. It's predictable, reliable, and intuitive. We can understand it, model it, and use it to build incredible things. The gears turn as they should, and cause and effect are clear. But beneath this familiar surface, beyond what we can easily perceive, lies a hidden world, a realm operating under completely different principles. It's the quantum realm, the world of the incredibly small, where the rules are radically different and our intuition often fails us. Here, in this bizarre reality, our coin can be both heads and tails at the same time, a concept that defies our everyday experience. This mind-bending state is called superposition. It's a fundamental aspect of quantum mechanics. It's only when we observe it, when we try to measure its state, that it chooses a side, seemingly at random. This act of observation forces the superposition to collapse, resolving into a single, definite reality. This isn't science fiction conjured from imagination. It's the true, experimentally verified nature of the universe at its smallest scales, revealed through rigorous scientific inquiry. The quantum world is the domain of atoms and the subatomic particles that compose them, where certainty gives way to possibility, and the future is not predetermined but rather a spectrum of potential outcomes. Particles, in this strange world, can exist in multiple places at once, a phenomenon known as quantum entanglement. They can also move and behave like both particles and waves, blurring the lines between these traditionally distinct concepts. Reality itself seems to wait for us to look, as if our observation plays a crucial role in shaping what is real. It's as if the universe holds its breath, suspended in a state of potential, before it decides what to be, based on our interaction with it. Understanding this realm, unraveling its mysteries, has become one of humanity's greatest intellectual adventures, pushing the boundaries of our knowledge. It challenges everything we thought we knew about existence, forcing us to reconsider the very nature of reality and our place within it. Are things truly real? Do they possess definite properties, even when we aren't looking, when there's no observer present? Can something fundamentally be in two places at once, defying our classical understanding of location and space? These questions aren't just abstract philosophical musings confined to ivory towers. They're the key to unlocking future technologies that promise to revolutionize computing, medicine, and countless other fields. The quantum world is undeniably strange, undeniably beautiful in its complexity, and it's already shaping our future in profound ways, driving innovation and pushing the boundaries of what we thought was possible. Welcome to the edge of what's possible, to the frontier of human understanding, where the quantum realm awaits our exploration. For centuries, classical physics, epitomized by Newton's elegant laws, provided a framework that seemed to perfectly explain the world we see. It was a triumph of human intellect, offering clarity and order. Everything appeared predictable, certain, and orderly, like a grand clockwork mechanism ticking away with unwavering precision. It's the physics of falling apples, a simple yet profound demonstration of universal laws. It governs the majestic dance of orbiting planets and the reliable operation of everyday machines, from the simplest lever to the most complex engine. But as scientists probed deeper, venturing into the realm of the infinitesimally small, they found that these rules, so reliable in the macroscopic world, begin to break down at the atomic level, revealing a reality far stranger than anyone had imagined. Classical certainty gives way to quantum probability, where outcomes are no longer guaranteed but exist as a spectrum of possibilities. In the quantum world, particles like electrons don't have fixed positions. Their location is inherently uncertain. Instead, they exist in probability clouds, a haze of potential locations spread around the nucleus. Their properties aren't set until we measure them, a concept that challenges our intuitive understanding of reality. The universe at its core is governed by chance, not certainty, by probabilities, rather than predetermined paths. This isn't just a curiosity, it's a fundamental shift in our understanding of reality, forcing us to reconsider the very nature of existence. The world we experience emerges from this deeper, stranger quantum layer, a foundation built on uncertainty and probability. It's as if our familiar reality is a movie, projected onto the screen of our perception, made up of countless unpredictable pixels, each governed by the strange laws of quantum mechanics. The quantum and classical worlds are two faces of the same universe, inextricably linked yet fundamentally different. One is predictable and visible, governed by the familiar laws of motion and gravity. The other is fuzzy and hidden, a realm of probabilities and uncertainties that underlies everything we see. To truly understand the cosmos, to grasp the full scope of reality, we must embrace both the classical and the quantum, the certain and the uncertain. The quantum revolution has changed our perspective forever, revealing a universe far more mysterious and wondrous than we ever imagined. The quantum realm, a world so small, it operates under a completely different set of rules than the world we experience every day. It is defined by rules that defy common sense, challenging our deepest intuitions about how the universe works. It's a place where the impossible becomes possible. Superposition means a particle can be in multiple states at once. Think of it as a blurry existence, where definite properties are yet to be determined. Like a switch that's both on and off. It's not one or the other, but a probabilistic blend of both possibilities. Only when we measure it, when we try to pin it down, does it settle into a single definite state. The act of observation forces its hand, so to speak. Then there's wave-particle duality, a concept that blurs the line between what we consider a solid object and a spreading wave. Particles like photons act as both particles and waves, exhibiting properties of both depending on the experimental setup, depending on how we observe them. It's as if the universe is playing a trick on us, revealing different facets of reality based on our perspective. Our classical categories simply can't contain quantum reality. The quantum world demands a new way of thinking, a new language to describe its bizarre behavior. Entanglement is perhaps the strangest rule of all, a phenomenon that Einstein famously called spooky action at a distance. Two entangled particles remain linked, their fates intertwined in a way that defies classical understanding, no matter how far apart they are. Distance is irrelevant. The connection persists across the vastness of space. Measure one, and you instantly know the state of the other. It's a correlation that seems to transcend the limitations of space and time, even across galaxies. This instantaneous connection has profound implications for our understanding of the universe. These aren't just abstract theories. They're not just mathematical curiosities. They're proven by experiment and form the foundation of quantum technology, driving innovation in computing, communication, and sensing. Superposition, duality, and entanglement. These are not just buzzwords, are the quantum toolkit. They are the fundamental building blocks of a new technological revolution. They're the secret language of the universe, the underlying code that governs the behavior of matter and energy at the smallest scales. And we're just starting to translate it, to decipher the mysteries encoded within the quantum realm. The weirdness isn't a bug, it's not a flaw in the system. It's a feature of reality, an essential aspect of how the universe is fundamentally designed. By embracing it, by accepting the counterintuitive nature of the quantum world, we unlock new ways to understand and shape our world, to create technologies that were once considered science fiction. The quantum world is not just strange, it's not just a curiosity for physicists. It's the engine of tomorrow's breakthroughs, the key to unlocking a future filled with unimaginable possibilities. Classical computers use bits, zeros or ones, to process information. But some problems are so complex, even supercomputers can't solve them in a lifetime. Quantum computers use qubits, which can be 0, 1, or both at once, thanks to superposition. This lets them process vast combinations simultaneously, making them exponentially more powerful for certain tasks. Imagine simulating molecules for new medicines or materials, or cracking codes that are unbreakable today. Quantum computers could revolutionize AI, climate modeling, and more, but building them is a huge challenge. Qubits are fragile and easily disturbed. Scientists are racing to protect and control them, working at the edge of what's possible. Whoever masters quantum computing will shape the future. The quantum race is on, and its impact will be global. Quantum technology isn't just about computing. It's much more than that. It's poised to transform both medicine and the very nature of space exploration. Quantum sensors could potentially detect even the faintest signals from the brain or heart, enabling earlier and far more accurate diagnoses than ever before. Quantum simulations could design drugs that are precisely tailored to your individual DNA, directly targeting diseases right at their source. In the vastness of space, quantum navigation could guide spacecraft with incredible pinpoint accuracy, even when they are very far from Earth. Quantum communication promises completely unhackable data links across the entire solar system. Even propulsion systems might one day harness quantum effects, allowing for much faster travel. These groundbreaking advancements may sound like something straight out of science fiction, but they're all firmly grounded in very real quantum principles. By mastering the intricacies of the quantum world, we're opening doors to a healthier and more connected future for everyone. Quantum science is sparking a new era, like the birth of the digital age. It's not just about faster computers, it's about understanding and shaping reality itself. Every new tool, from telescopes to particle accelerators, has revealed wonders we never imagined. Quantum tech will give us a new lens on the universe, unlocking discoveries from new particles to the secrets of dark matter. Governments and companies worldwide are investing billions, fueling a wave of innovation and inspiring a new generation of scientists. The potential is limitless. Superconductors, earthquake sensors, sustainable agriculture, and more. Quantum science could solve humanity's biggest challenges. We're not just learning about the universe, we're learning to partner with it. The quantum revolution is a collective journey to a smarter, more sustainable world. Exploring the quantum realm expands our cosmic perspective. We once looked at the stars in wonder. Now we probe the heart of matter itself. This knowledge will empower us to reach farther than ever before. The quantum future isn't just for scientists. It needs artists, ethicists, and an informed public. We must ensure quantum advances benefit everyone, not just a few. Like the internet, quantum tech could connect us in new ways and solve global problems. Our choices today will shape the world quantum technology creates. The journey is just beginning, and the challenges are great. But human curiosity is relentless. We are explorers at heart. The quantum world is a new frontier, full of wonder and possibility. The same laws that govern distant stars operate within us. By understanding quantum reality, we learn about ourselves and our place in the cosmos. Together, we're charting a course for a future powered by the strange, beautiful rules of the quantum realm.